and thanks very much for the invitation to present today, and actually thank you to all of you for hanging around to hear the later presentations today as well. So the paper that I'm presenting today, the title is Comparing Experimental and Quasi-experimental Estimates, a Study of Childhood Asthma. This is a joint work with Orla, who all of you know. And just before kind of going into the details of this paper, I just want to spend a little bit of time just giving a quick overview of what this study is about. So the research question is, can the results from an experimental early childhood intervention be replicated using propensity score matching? So this paper has very much a kind of methods focus to it, and we're really kind of using the Preparing for Life study as a case study for looking at different methods for impact evaluation. So the outcome that we're looking at is diagnosed asthma at age 3, so this kind of follows up from the study that Caroline was just talking about. And just this outcome measure is slightly different, given that it is diagnosed asthma, rather than that measure of whether or not a child has been to a health centre with an asthma or wheezing complaint. And we feel like that asthma is an interesting outcome to examine for two reasons. So first of all, asthma is the most common chronic health condition in children worldwide. And also the rates of asthma are particularly high in Ireland, so it's an interesting question to look at in an Irish context. So now, as the name of this paper suggests, we're looking at two different methods for impact evaluation. So there's the experimental method, and that's method 1, where we take advantage of the fact that our PFL has been designed as a randomized control trial, and that is our way to extract what we call our experimental estimate of the treatment effect. And then the quasi-experimental side of things, that is method 2. And the specific method that we're looking at is kernel matching using Growing Up in Ireland data, so that's what the GUI stands for, to construct an alternative control group to the control group that we get from the randomized control trial. Okay, so the results that we get is that using the experimental approach, we estimate a 13% reduction in asthma incidence as a result of exposure to, specifically, we're talking, the kind of treatment that we're talking about here is the home visiting and parent training components of Preparing for Life. And then using the quasi-experimental approach to impact evaluation, and that is what this PSM is representing here. PSM stands for propensity score matching, and kernel matching is a type of propensity score matching. So with that approach, we estimate a 14% reduction in asthma incidence. So really the bottom line from this paper is that we're getting a similar estimate when we use the quasi-experimental approach to the experimental approach. Okay, so the motivation for this study. So in recent years, there's been an increased emphasis placed on early childhood policy. And so because of this, there has been an increase in the demand for evaluations of early childhood initiatives. But despite this increase in demand, there have been few initiatives that have actually been experimentally evaluated. And we can kind of think of a few different reasons for why this might be the case. So first of all, many childhood policies are just simply universal in nature, so it's not possible to do any type of experimentation. A second issue is, well, as pointed out by Angus Deaton, is that randomized experiments are often costly, and then because of this, it means that sample sizes have to be kept quite small. Now, Angus Deaton is known as kind of one of the most prominent critics of the randomized control trial approach to impact evaluation, and in particular because they have become so popular in development economics in recent years. But of course, an obvious kind of counter-argument to this point would be that there's also a cost associated with investing in the wrong type of program or a program that has a small effect. Okay, so it can be worth investing in the evaluation also. Also then, as pointed out by Angrist and Pischke, there's often a demand for evidence sooner rather than later. So many policymakers don't really want to wait for the results from a lengthy, kind of albeit a very kind of carefully conducted trial to become available. So there may be an argument there for making use of data that already exists in order to do some type of impact evaluation analyses. Okay, so given that sometimes a randomized control trial just isn't feasible, researchers, when they're faced with this type of scenario where they don't have access to a randomized control trial or it's not possible to conduct one, they have to use some alternative approach to impact evaluation. And a popular approach would be to use some type of propensity score matching technique. Now, the issue with propensity score matching as compared to a randomized controlled trial approach to impact evaluation is that you have to make a lot more assumptions. It's a lot more difficult to argue with conviction that the result that you're presenting is the true result. So kind of a good way to test out whether a propensity score matching technique is valid for a certain type of setting is to take advantage of the fact that you already have an experiment that's been carried out. That's what we have with PFL. And then sort of imagine that that experiment had never taken place, and imagine what sort of result a researcher would find if they didn't have access to this experiment and they were having to use this propensity score matching technique instead. Now, if there's any fans of econometrics in the audience, I see a few at least anyway, you will realize that this sounds kind of quite similar to a well-known study by Robert Lalonde from 1986, where he did this type of thing where he looked at the results from an experiment and then tried to replicate the results using alternative approaches to impact evaluation. And that really kind of ignited a whole body of literature in that vein, and that's what we are contributing to with this study. Now, I'm not going to talk too much about PFL because we've heard a lot about PFL today with the previous speakers, but I just want to highlight again that Preparing for Life does target a disadvantaged community. And that is just important because the other data set that we're looking at that comes from the Growing Up in Ireland study, Growing Up in Ireland is carried out with a nationally representative sample. So it's kind of different cohorts that are targeted with the two studies. And that's just kind of important for some of the analyses later on. Okay, so we heard a bit about the design of the randomized control trial earlier, but let me just remind you, 233 pregnant women were recruited to take part, and then they were randomly allocated to either a high treatment or a low treatment group. Now, for simplicity in this paper, because we're looking at many different groups, we simply refer to the high treatment group as the treatment group, or the TG for short, and the low treatment group as the randomized control group, or the RCG for short. And this also is because the main kind of treatment that we're looking at is the additional provisions that are delivered to the high treatment group. Okay, so that's kind of what our treatment is. And let me just remind you of the common provisions versus the additional provisions for the high treatment group in this slide. So just to remind you, both groups, both the high treatment group and the low treatment group, get developmental materials worth €100 annually. Both groups get the opportunity to participate in public health workshops. Both groups have the access to a support worker who gives information about existing services in the community. And then the high treatment group gets 2 additional provisions: regular home visits from a trained mentor and the opportunity to participate in a parent training course once the study child reaches the age of 2. So these 2 additional services that are highlighted in yellow here, this is what we're referring to as the treatment. And I know sometimes if you aren't maybe that familiar with impact evaluation literature, that terminology can sound kind of quite clinical, but it's the standard way of discussing these things when you need to kind of define what the treatment is that you're examining. Okay, so the data that we're examining for this particular paper, so this timeline shows the different points at which interviews are carried out with the Preparing for Life participants. And then highlighted in yellow here are the 2 surveys that we're using for this particular study. So we're using data from the baseline interview, and then we're using data from the 36-month survey because this is where we get our outcome measure. So the measure of asthma diagnosis, that's coming from the 36-month survey. Okay, so then for Growing Up in Ireland, and actually I should just point out that the Growing Up in Ireland study is a longitudinal study, so it's like over 10,000 households. Actually, Trace knows quite a bit about the Growing Up in Ireland data, but over 10,000 households are first interviewed when the study child is 9 months of age, and then the same caregivers for these children are re-interviewed when the study child has reached 36 months of age. And these are the 2 data points that we're using for this study. So remember, with the quasi-experimental approach to impact evaluation, what we're doing is that we want to find participants in the Growing Up in Ireland study that are similar to those from Preparing for Life. And the way that we're finding these matched participants is by comparing the baseline characteristics from Preparing for Life to the 9-month characteristics from Growing Up in Ireland. So this 9-month interview is kind of serving as our baseline in Growing Up in Ireland. Now, obviously that isn't ideal because the timing of the interview is slightly different, given that, you know, when the baseline interview is carried out in Preparing for Life, the study child hasn't been born yet. And then in Growing Up in Ireland, the study child is 9 months of age at the baseline point. And so for this reason, when we're actually doing the matching, we focus on characteristics that you would expect to kind of stay stable over time. And then the nice thing with Growing Up in Ireland is there's also a question about asthma diagnosis in the 36-month survey. So that overlaps with Preparing for Life. Okay, so I've got some descriptive statistics here just to go through, and for the most part, we're looking at baseline measures here, but just this very first measure, whether the study child has been diagnosed with asthma at age 3, that is, of course, the outcome. And so you can see that 9% of the treatment group, the TG, have been diagnosed with asthma at age 3, 17% of the RCG, the randomised control group, and 6% of the Growing Up in Ireland sample. Then if we look at these baseline measures that are down underneath here, and what we're doing here also is that, remember, we've got the treatment group, and then depending on whether we're doing experimental analyses or quasi-experimental analyses, we're going to be using a different control group. So we wanted to then compare each of these control groups to the treatment group in relation to these baseline characteristics. And so if you look at the, oh yeah, and I should point out actually also, if we find a statistically significant difference, then we highlight the number in a bold font and then we use stars to represent the significance level. So for this RCG column here, you can see that none of the numbers are in bold font, there's no stars, and that is kind of what you would expect as a result of randomization. You would expect these two groups to be balanced in relation to baseline characteristics. But if we look at the Growing Up in Ireland column here, you can see that there's quite a lot of numbers that are in bold font and quite a lot of stars to represent statistical significance. And this is just really highlighting the fact that the treatment group, or like the Preparing for Life group in general, is a more disadvantaged group. So I think you can see here that whether the household resides in social housing, it's around 53% in the treatment group, whereas it's only around 10% for the Growing Up in Ireland sample. And then if we look at whether the mother has a degree qualification, 4% for the treatment group, whereas it's approximately 40% for the Growing Up in Ireland sample. Now in this next slide, I've got some more baseline characteristics. And again, for the most part, you can see that for this randomized control group column, there are very few statistically significant differences, but there are a couple of important ones that I just want to point out. So first of all, whether the study child is female, you can see that around 50% of the treatment group are female, whereas there's a higher percentage for the randomized control group at 64%. And that difference we just felt was an important one to account for because it is known from the literature that there is earlier onset of asthma in boys versus girls. So we wanted to control for that difference when we were doing our analyses. And then also at the bottom here, whether or not the mother has a chronic illness, a higher percentage in the treatment group, 85% versus 67% in the randomized control group. And also given that with asthma, it's kind of known that there can be genetic factors which determine the development of asthma in children. There can also be environmental factors, but we wanted to account for the fact that there is this difference here in relation to family background on a health measure. And then again, if you look at the Growing Up in Ireland column here, you can see that there's a lot of numbers in bold font, a lot of stars. So again, this is just representing the fact that the treatment group is a more disadvantaged group as compared to the Growing Up in Ireland sample. Okay, so just quickly a little bit of information about the econometrics. So the first step is to carry out the experimental analyses, and so the way that we do this is we compare the two PFL experimental groups, so that's TG and the RCG, and this gives us what we call our best benchmark against which we compare the results then that we get from quasi-experimental analyses. So the next step then is to do the quasi-experimental analyses. So that is when we use Growing Up in Ireland to construct pseudo-control groups. As I mentioned, we're using kernel matching, which is a type of propensity score matching. And actually, Therese gave a very good explanation of propensity score matching earlier on. So just a reminder that the idea with propensity score matching is you, first of all, generate what you call a propensity score for every single participant in your treatment group, every participant in your Growing Up in Ireland sample. And you can almost think of this propensity score as like a kind of a composite index of all of the different characteristics that you want to match on. And it's, as Trey said, it's often referred to as a balancing score, as a way to ensure that your two groups are balanced in relation to the characteristics that you feel are important for selection. And so then then you kind of find your matches in your Growing Up in Ireland sample based on the similarity of this propensity score. So you're looking for people in Growing Up in Ireland that have similar propensity scores to those in the Preparing for Life treatment group. Now there are various different methods of propensity score matching. So there's methods like one-to-one matching, k-nearest neighbour matching, radius matching, as Therese was talking about earlier. And just for our particular scenario, where we've got a very small treatment group, whereas with Growing Up in Ireland, that gives us a very large pool of potential control units to use for matching, it makes more sense to use kernel matching in this type of scenario, because it's kind of known that methods like one-to-one matching, they are kind of the least biased approach to propensity score matching. But if you kind of employ more data for your analyses, that improves the efficiency. So with kernel matching, what you do is you give a larger weight to the observations, or the participants who are Growing Up in Ireland that have a propensity score that is most similar to the participants from Preparing for Life. But you still kind of retain quite a lot of data. Now, I won't have time, I think, to go through, because I think I've only got about 25 minutes or so to get through this, but we do look at some alternative matching estimators also as a robustness test. Now, there are some complications to the analyses that we carry out, and apologies in advance that this slide is a little bit technical, so again, if there aren't many fans of econometrics in the audience, you may not enjoy the few points that I'm going to make here. But these complications are actually also as well what make the study kind of interesting, because there are issues that aren't very often discussed in the propensity score matching literature. So they're kind of unusual complications. So first of all, the Preparing for Life sample is not representative of the Irish population. So it's difficult to find good matches in Growing Up in Ireland for the Preparing for Life treatment group. Then also a technical point here, and I just have to go through these points as well because it helps to explain the way that we're presenting our results tables that are going to be coming up next. So with kernel matching, you have to define a bandwidth, and a common approach for defining the bandwidth is known as Silverman's rule of thumb. But we kind of play around with two different kind of variations of Silverman's rule of thumb so that we end up with both what we call a narrow bandwidth and a wide bandwidth. And so the issue is that when you use a narrow bandwidth, it means that you're putting more limitations on the observations that can be used in your analysis. Whereas when you allow for a wider bandwidth to be used, it means that you're allowing for more observations to be retained for the analysis that you carry out. And then also another issue that isn't very often discussed is that when you've got this issue whereby there are a few good matches in this, so in this Growing Up in Ireland sample that we are using, there's a few good matches, it can make more sense to use a parsimonious model for generating your propensity score. So what that kind of means is that it makes more sense to not kind of throw the entire kitchen sink of baseline characteristics at the generation of the propensity score, and instead to use a less kind of detailed model in order to ensure that it's possible to find more suitable matches. So a couple of technical issues there. So let me just go through the experimental results first of all. So remember, with these results, we're not looking at Growing Up in Ireland at all. We're just comparing the Preparing for Life treatment group and the Preparing for Life randomized control group. And so the outcome is whether the child has been diagnosed with asthma at age 3, as we know, and then we've got the various right-hand side variables that are included in our regression down here. And the one that we're most interested in is the treatment indicator. So that obviously is going to have a value of 1 if you're looking at a participant in the treatment group, and a value of 0 if you're looking at a participant in the randomized control group. And then the coefficient on this indicator is our estimated treatment effect. So in the very first regression, we're just doing a raw comparison of the means for the two groups, and the estimated coefficient is -8%. But at this point, we're not accounting for those 2 important significant differences that we found at baseline. They're added in model 2 here. We add in whether the mother has a chronic illness, whether the study child is female, and now the estimated treatment effect is 11% reduction in asthma, and the 1 star means that it's significant at the 10% level. Then what we're doing in columns 3 through to 6 here is that we're adding in additional controls, and we're adding in these additional controls in order to be consistent with the measures that we use for matching when we're doing the quasi-experimental analyses. So you can see there in the top row that for column 3 through to column 6, the estimated treatment effect is a 13% reduction in asthma, and the 2 stars means that that's significant at the 5% level. So this estimate is what we call our experimental benchmark, and that's what we want to kind of see whether our quasi-experimental results will end up being similar to that. Okay, so for the quasi-experimental results, now apologies that I know there's a lot in the slide and the font is quite small, so I'll try to go through it kind of slowly here just so you know what's going on. So our outcome, of course, is the same as before. We're looking at whether the child was diagnosed with asthma at age 3. And then in panel A, we're just matching on 2 baseline characteristics, the maternal health measure and the child gender. Then in panel B, like in the previous table, we add in SES measures for finding matches. Then in panel C, we add in a measure of the household composition. In panel D, we add in the mother's age, and there's also a panel E that I couldn't fit onto the slide. Then for each of these different approaches to matching, then we have our 2 different bandwidths. So the larger number is the wider bandwidth, and then the smaller number is the narrower bandwidth. And so then we end up, oh yeah, I should explain what we have over these other columns as well. So we've got the number of observations that remain in the treatment group after carrying out the matching, the number of observations that remain in the Growing Up in Ireland sample after we carry out matching. Then we've got our ATT, which stands for the average treatment effect on the treated. And then in the final column here, the mean level of standardized bias after matching, and this is a way of kind of checking if your treatment group and your pseudo-control group are well balanced in relation to the key characteristics that you feel matter for selection into treatment. And the rule of thumb with this measure, with this mean standardized bias, is that it should not exceed 5%. If it's exceeding 5%, you've got concerns that your conditional independence assumption does not hold. Okay, so we end up with all of these different kind of estimates of the treatment effect, and so then we have to kind of think to ourselves, if a researcher did not know what the experimental estimate is, which of these estimates would they end up picking if this was the only information that they had? And so we kind of outline a guide that we feel a researcher should follow if they were kind of doing this type of analysis, whereby they should be considering things like how many observations remain after they do the matching. Also, they should be considering what is the mean level of standardized bias. And also, a researcher would probably want to be using as detailed a model as possible for generating the propensity score, but without getting to that scenario where you're using a ton of observations and where the average level of bias is too high. So we can recommend in the paper that a researcher should follow tables like this, start at the bottom and kind of work their way up. So if you're starting at the bottom here, because with this model at the very bottom, there's only 33 observations that remain in the treatment group, and mean level of standardized bias is very high at 12.4%, then they would be unlikely to trust this estimate of a 10% reduction in asthma, which is insignificant according to this estimate. Okay, so you would rule that one out and then you would move up. So then moving up and using the wider bandwidth, you can see that not too many observations are lost from the treatment group. Also, the mean level of standardized bias is kind of right on that threshold of 5%. So we feel that a researcher would feel that this is a valid estimate of the treatment effect, a minus 14% reduction in asthma that is significant at the 5% level. Okay, so that's how we're seeing that we end up with an estimate that is very, very similar to that experimental estimate of a 13% reduction in asthma that we saw on the previous slide. Okay, so I think I'll skip over this slide because we've had enough technical detail maybe for one day. And let me just conclude. We know the randomized controlled trials are the gold standard of impact evaluation. There's no denying that the ideal method for doing impact evaluation is a randomized controlled trial. But there are pitfalls associated with the RCT approach. Just an example of some of the criticisms that are targeted towards randomized controlled trials would be the issue of high cost and the associated issue of small samples. So what we have shown in this paper is that all is not lost if you don't have a randomized controlled trial. We show that with propensity score matching, we get similar results to what you would get using the experimental approach. But it's only possible if you're very, very kind of careful with econometrics, so you have to be very careful in considering bandwidth selection. Also, you need to think about overlap in the propensity score. And also, this type of analysis was only possible due to the rich data that were available on pre-treatment characteristics, so that we were able to argue convincingly that the important characteristics for matching were available to us. So I suppose, there's an ongoing debate in economics in particular as to whether RCT should be used or whether an alternative approach should be used. I completely think there's pros and cons to both approaches, and it kind of just depends on the particular scenario that you're faced with, which approach makes the most sense. So I guess I'm sitting on the fence a little bit with the whole debate there. So that's everything now for today, and I welcome any questions. Oh, and I just must say my thanks to Orla and the early childhood research team here at URI. Thanks for all of your help with this research, and also thanks to Noel Kelly and the PFL implementation team for all their support with this research also.